Hey, Tom. Thanks for your message. I'm not sure what classes you have now, so I thought maybe I'll just create this little recording for you and you can watch this and it will help you with your question. Thanks so much for asking as well. And this may be the most boring video ever uploaded to YouTube, but hopefully it will help you. All right. So I've taken a screenshot of your question. Basically, what we're trying to do when we practice these questions is we are trying to plot an equation, an algebraic equation, on a Cartesian plane. So one of these guys. And obviously you will plot your equation on Desmos when you get up to that stage. You may remember that story I shared with you guys about how in English and humanities and art, you guys express messages in different ways all the time. So in art especially, or in music, let's talk about music because that's what you're into. You can express sadness in music without necessarily singing about how sad you are, but just the mood of the music will make someone feel a sense of sadness. And that's what we're in a not as cool way. That's what we're doing with, just get rid of that. That's what we're doing with linear relationships. We are going to look at 3 different ways we express or can express a relationship between 2 different variables. So the relationship we're looking at is between y and x. Now that's just context. So hopefully that becomes clear to you over the next couple of weeks. If it doesn't yet, that's completely fine, but that's where we're heading. So first, we are going to create a table of values that presents the same relationship as this equation. And so to do that, we just make up a bunch of values for x. So here, we're just going to pretend in the first column, we're just going to pretend that x is -3. So if x is -3, then we have to times that by 3. So that's what the working out is here. 3 times -3 equals -9. Then we have to add a +1 onto -9, and that becomes -8. And then for the next column, we're just going to pretend that x is -2. So we're going to substitute -2 into the equation where x is. So it becomes 3 times -2 equals -6. Then when we add 1, that becomes -5. And so when x is -3, based on this relationship, when x is -3, y is equal to -8. Then when x changes, and it might be -2, it means that y is -5 based on this relationship. Then when we pretend that x is -1, we have 3 times -1, which is -3. There's less working out in this column. So -3 plus 1 is -2, which means when x is -1, y is -2. So the 2 middle rows here are only there for you to practice doing each calculation step by step. So this is called a 2-step linear equation because it has two operations or 2 calculations before you find the final answer. So it's times 3 times x, that's the first one, and then the second operation or step is adding 1 onto the end of it. So then I'll go through one more example. When we pretend that x is equal to 0, it becomes 3 times 0, which is just 0. Then you add 1. So then y is equal to 1 only when x is equal to 0. So if you're confused about what the working out is meant to look like, there's just going to be a bunch of +1s in the third row. And then for the working out in the second row, you can just chuck what the answer is there. So you just got to times each of these x values by 3 and put the answer in each one, in each column, and then do the final calculation to find out what y is. And then when you go to Desmos, I'm sure you know how to use Desmos now because we've been using it over a few lessons. When you go there, the page looks like this initially. You can press those arrows on the left. Then you can add a table of values. To do that, you just press the Add Item button. Press that, and then the table option is there. Click the table option. And then for adding the table of values in these sorts of questions, you add the top row because they're the x values, and you add the bottom row because they're the y values. So you add this row in the first column on Desmos and this row in the second column on Desmos. As an example, -3, enter, -2, enter, -1, enter, etc., etc. And then if I won't do the whole thing, but I'll do the first couple, -8, -5, -2, and 1. I'm going to forget what they are. -8, -5, -2, and 1. Alrighty, and it's cool because as you add in the coordinate points or the table of values, the coordinate points pop up on the graph immediately. So the reason why this is called linear relationships is because when you graph the equation or the table of values, it creates a straight line. So a linear line, that's how it's connected. So if I go back to the bigger picture here, we have now got 3 different representations of the same relationship. We have the original equation, y equals 3x plus 1. And we have our table of values. Go actually to Desmos to do that. We have the table of values. And we now have a straight line on a graph. So they are the 3 ways that we can represent a linear equation. One last thing, because this is just a vocab thing. We've been in algebra, we were looking at algebraic expressions, and now I'm starting to use vocab of algebraic equation. The only difference between an algebraic equation and an algebraic expression is that an expression would just be 3x plus 1. Notice how this doesn't have an equal sign, but then the linear equation in this example is y equals 3x plus 1. So an equation just has an equal sign. Alrighty, that's going on 10 minutes, probably a couple of minutes too long, but it was a extensive explanation for you. So if you have any more questions, let me know, but thanks so much for getting in touch with me to ask some questions. You're a legend. All right, bye.